Hi, we are still talking about basic assembly here, and today we are going to talk about the flags register. Objectives of this lesson. We will learn about the flags register. We will learn about some specific flags inside the flags register. The zero flag, the sign flag, the carry flag, and the overflow flag. A total of 4 flags, which are really the basics of the flags register. If you really want to do anything related to branching or something like that, you will have to know about at least one of those 4 flags. In the future, we are going to use the values of those flags to make branches and decisions in our code. So this is a pretty important lesson. If you want to be able to decide things in your program or maybe create loops, meaningful loops, not just infinite loops, you are going to have to know about those flags and how they work. So make sure that you understand pretty well how those flags work. The flags register. The flags register is a 32-bit register inside the x86 processor. Actually, as usual, it has 64-bit extension for the long mode. Although, I think that at least in this point, in 2014, the 64-bit extension for the flags register doesn't actually have any new flags. I think that all the additional 32 bits are just reserved at this point. Another important thing is that there is no usual direct access to this register. That means that you can't really read it using the move instruction or assign it using the move instruction. You have to do other things to access this register. Every bit in this register is a flag. It means that every bit represents true or false. As a rule of thumb, 1 is going to represent true and 0 is going to represent false. This flags register contains bits with values that reflect the result of the last calculation. For the most part, this is true. Usually some calculation happens and then the flags in the flags register are changed automatically. For example, by looking at the flags register, you can answer these kind of questions. Has the last calculation resulted in 0? Has the last calculation resulted in a negative number? Or maybe has the last calculation resulted in a number that doesn't fit into a 32-bit register? And it can help you answer even more strange questions, which is going to be important in the future. Let's take a look at how the flags register looks like, at least the lower part of the flags register. I didn't want to overwhelm you with all the strange flags that it contains. So this is really the lower part. This is bit number 0. I remind you that when referring to bit number 0, I actually mean the lowest significant bit, which means maybe if you write numbers usually, like we did previously, then the lowest significant bit is the rightmost bit. You don't actually have to remember what you see, or even you don't have to remember the bit numbers. It is not going to be important at all. You just have to know about the existence of these flags. There are pretty much flags. I only mentioned the flags until number 11. There are more flags if you go on. First, I will mention the ones that are reserved. There are some bits in the flags register that are not used. This is what means that they are reserved. They are reserved for maybe some kind of future use. Maybe one day some kind of new flag will be needed, and then the developers of the processor could use this placeholder as a new flag, or maybe this one. But currently it is not used, so it is reserved. The reserved flags are marked with gray in this table. There are 3 reserved flags, at least in this range. There are even more reserved flags if you go on with the bits. The denser part of the flags register is in the lowest part, mostly because of compatibility reasons. You can probably imagine that in the older days of the very first x86 processors, all of the flags were in this side. They were inside this part of the register, from bit number 0 to bit number 7. More flags were added later, when the flags register became larger. You can see that there are pretty many flags here. Some of those flags are not actually what people call status flags. That means that they don't really reflect results of calculation. For example, these flags, the direction flag or maybe the interrupt enable flag, are not results of calculation or reflection of results of calculation. They are kind of control flags. You can change them to change how the system acts or behaves. But we are not going to deal with those kind of flags at this point. The really important flags, at least for me at this point, are those 4 flags. The carry flag, the zero flag, the sign flag, and the overflow flag. These are 4 flags that are very important, at least for branching and decision making. You are going to be an expert in those 4 flags. If I wake you up at night, you are going to know what every flag out of these 4 flags means. As an assembly programmer, you have to be very proficient in those 4 flags. They are very important. Some ideas about changes in the flags register. Every instruction can have certain effects on some bits of the flags register. There are some general rules of thumb regarding how each flag is changed by different instructions. With some experience, you will be able to get a feeling of how the flags are going to change. I just said it to make sure that you know that you don't have to memorize everything. Each of those flags is some kind of an idea. There was some big idea behind each of those 4 flags that we are going to talk about. However, still in every different occasion or every different instruction, the flags are affected a bit differently. There are some little subtleties for each instruction about how it changes the flags. However, if you have the general idea of what a flag means, then you don't have much problems. You are going to have some kind of a feeling of what is going to happen. And the feeling is going to be correct in most of the time. So I think this is the right way to learn, to get a feeling of what each flag means. And then when you understand it, you can predict pretty accurately what is going to happen whenever an instruction occurs. The flag register is somehow like the mood of the processor. It changes when things happen. That means that instructions happen and then it somehow affects the mood of the processor, and the mood is represented by the flags register. Let's begin with the 0 flag. The 0 flag is set. When I say set, I mean change to 1. This is a pretty general notion about bits. We say set for 1 and cleared for 0. So the 0 flag is set whenever the last calculation had the result of 0. I want to emphasize here this word, calculation. The 0 flag cares about calculation. It doesn't care, for example, about data transfer. If you transfer the value 0 inside some container, for example, if you move the value 0 inside ECX, it is not going to affect the 0 flag at all. The 0 flag really cares about calculation. If the last calculation is 0, the 0 flag is going to be set to 1. The 0 flag will be cleared whenever the last calculation had a non-zero result. Let's look at an example. We have those 3 instructions, move, move, and sub. The first one moves 3 into EAX, the next one moves 3 into ECX, those two first instructions have no effect at all on the 0 flag, because they are not calculation, they are about data transfer. And then we have this last instruction, sub, which subtracts the values of EAX and ECX. It actually calculates 3 minus 3, and the result is 0. Therefore, right after the execution of this sub instruction, the 0 flag will be set to 1. Let's look at another example. We can see again pretty much the same. The first two instructions are exactly the same, but the last one is an add instruction. So this time we calculate 3 plus 3. Right after the execution of the add instruction, the 0 flag will be cleared to 0. The first example sets the 0 flag to 1, and the second example clears the 0 flag to 0. Maybe before I talk about the sign flag, some words about the 0 flag. The 0 flag is really one of the simplest flags that exist. It is really easy to understand it. It just checks if the result is 0. And for the most part, you could actually survive only knowing this flag. You could write pretty useful programs only with this flag. The other flags are kind of a bonus. They help you out, but I think that for the most part, you could survive with this flag. It is very basic. It is actually the basics of everything. It could let you check if something is 0 or not 0, which could actually give you the ability eventually to check if any bit is 0 or 1, which is the most fundamental test that you can do inside a binary system or inside a computer. We have some other flags to make our lives easier, so we could do some more interesting things and have larger vocabulary of the things that we could think about.